Okay, so now let's finally get to 22 through 26. So 22 says the following is a sample of unemployment rates in percentage points in the U.S. sampled from the period 1990 to 2004. So we have 4.2, 4.7, 5.4, 5.8, and 4.9. And it says calculate the sample mean, which is x bar, which is just going to be equal to the summation of all those things. So 4.2 plus 4.7 plus 5.4, well, that's a plus 5.4 plus 5.8 plus 4.9, all divided by how many points we have. It looks like we have 5, right? All divided by 5. So take a second. I'm going to do this in the calculator over here. Plus 4.9 divided by 5. It looks like we have a nice number of 5. So x bar is equal to 5. Now, if he lets you use the calculator, right, then, that'll make it a little bit easier. If not, right, our mean here, right, so in other words, our sample mean, S, should be, let's think, let me remind myself. Okay, so if we want to calculate sample standard deviation, which is what we want here, we want, the square root of the sum of all of our xi's, which are our data points, minus x bar, which we just found, squared, all divided by n minus 1, right? I would also verify and double check with the calculator. If he lets you use the calculator, then by all means, go for it. But in this case, we need to perform, let's move this really quick out of the way. We need to do all these summation, there are all these subtractions and summations, right? So in other words, I need 4.2 minus 5 squared plus 4.7 minus 5 squared, and so forth, right? Plus 5.4 minus 5 squared. We're going to make this smaller. Plus 5.8 minus 5 squared, and finally 4.9 minus 5 squared. So we'll do all these first. I'm just going to simplify, right? This is negative 0.8 squared plus negative 0.3. Now the negative really doesn't matter here. We're going to start to square everything. Plus 0.4 squared plus 0.8 squared plus negative 0.1 squared. And I'll take it a step further, just less things for me to put in my calculator. 0.09 plus 0.16 plus 0.64 plus 0.01. 1.28. And at this point, right, at any point you could just plug this into your calculator. But I'm trying to, it'd take me actually more time to plug it into the calculator than it would just to solve. Okay, really quick, right, 0.64, 0.64, it's going to be 1.28, 0.09, 0.1, 0.10, and 0.16. So 1.54 is what we have here. So that is what all this sums up to be here after we've squared each individual thing. And so then we need 1.54 divided by n minus 1, which is 4. And then we need the square root. So I'm just going to type this into my calculator at this point. And so I get, and I'm going to verify, 0.6204. I don't know how many decimals they want. Let's check. This is 22, I believe. And they just want, what did I do? supposed to be, he has 6.2. X equals 5. Oh, no, 0.6. He wants one decimal. Okay, I'm looking at the wrong one. So he just put 0.6 for your sample standard deviation. So there's 22. We're going to keep moving on to 23. 23. It says, using question 22, so let's remind ourselves, we found that x bar was equal to 5, and our sample standard deviation, sample mean was 5, and sample standard deviation, we're just using 0.6. It says, in what range does the empirical rule predict that approximately 95% of the unemployment rates will fall? Well, 95, the empirical rule tells us, all right, if we have this, that within 2 standard deviations of the mean, all right, so 1, 2, this will contain 95% of our data. Now, two standard deviations in both directions. So in this case, I need to take 5 and add 2 standard deviations. That will give me my upper bound. And I also need to take 5 and minus 2 standard deviations. That will get me my lower bound. So my upper bound here is 6.2. My lower bound is 3.8. Now, if you go back and you look at your data, right, just as a reminder, 4.7, oops, I missed one, 4.2, 4.7, 5.4, 5.8, and 4.9, right, you can see that this interval from 3.8 to 6.2, which has 95% of our data, well, it actually covers all of our data, right? It actually includes 100% of our data. So part B here says, well, what is the actual percentage of employment rates in the range predicted from part A? And this would be 100%, right? Because 100% of our data falls in this range here, even though according to the empirical rule, it says 95%. And it says for C, which gives a more accurate prediction, we actually do want the empirical rule. Gives a more accurate prediction than Shevchev's. Okay, 24 says, using the probability distribution table in question 20, okay, so we'll have to remind ourselves, assuming that the probability of x equals -2 and x equals -1, calculate the standard deviations rounded to 2 decimals. Okay, so question 20, we have this. After we fill out the chart, right, this is x, and this is p of x equals x. We have -2, -1, 0, 1, and 2. These were given to you, right? These back 3, 0.4, 0.1, 0.1, which means these two, we've calculated this before. This is 0.2, and this is also 0.2. Now it says, right, to calculate, did it say the variance or the standard deviation? I believe it says standard deviation. Yeah, and all we need to know here is that the standard deviation of x is equal to the square root of the variance. So we're actually going to find the variance. And I've introduced this concept before, but the variance of x here is equal to the expected value of x squared minus the expected value of x squared. Okay, so I'm going to write another small chart over here, and all the same probabilities are going to hold, but now I'm just going to square everything, right? So instead of -2, I have +4. Instead of -1, I have +1. Instead of 0, I have 0. Instead of 1, 1, and instead of 2, I have 4. Right? Now all the probabilities stay the same. And so now when I go calculate the first part, let's do the expected value of x squared, right? I'm going to reference this chart over here. that's going to give me, so I'll say expected value of x squared. Well, that's going to be 4 times 0.2 plus 1 times 0.2. Now you're welcome to put the 0 there, but 0 times 0.4 is going to be 0. So plus 1 times 0.1 plus 4 times 0.1. In which case we get 0.8 plus 0.2 plus 0.1 plus 0.4, which gives us 1.5. So that's our expected value of x squared. And now we want to find the expected value of x, and then we'll square it. Right, so expected value of just x. I think we found this in part 20, didn't we? Let's go check. Yeah, so in part 20, if we already have this done, and I'm going to say that we know how to do this part, just to save us a little bit of time. Right, the expected value of x was negative 0.3. And so now if we want the variance of x, we're going to take 1.5, which is what we just found, minus negative 0.3 squared. So in other words, 1.5 minus, this is going to be 0.09, and so we should get 1.41, but be careful, right? This is the variance of x, and we are interested in the standard deviation, so we need to take the square root of 1.41 to get the standard deviation of x. In this case, second square root 1.41, I get 1.187. Okay, and finally 25, sorry for the glitch there. I think 25 was the one I had an issue with, but let's go ahead. It says calculate the expected value, right? So expected value and standard deviation of a given random variable x. It says x is the number of red marbles that Susan has in her hands after she selects 5 marbles from a bag containing 5 red marbles and 2 green ones. So we have a 5 out of 7 chance of selecting a red marble, 2 out of 7 chance of selecting green one, right? So this is a binomial. She's saying, right, an expected value problem for a binomial distribution because it says x is the number of red marbles that Susan has in her hand after she selects 5, and here n is equal to 5. And so I'm interested in the expected value of x, which would be n, I've selected 5, times the probability of getting a red one. And so in this case, we end up with 25 over 7. Which is 3.57. Right, so again, in the case that it's a binomial, right, in this case, red is a success, green is a failure. Success is 5/7. If I select 5 of them, I would expect that 5 times 5/7 will give me the expected value of how many red ones I have. Now, I think the issue was I looked at the answer key for this, and it says we're looking for standard deviation next. Well, for a binomial distribution, standard deviation of x should be the square root of n times p times q, which is going to be, let's see, square root of 5 times 5/7 times 2/7. And so in this case, 5 times 5 divided by 7 times 2 divided by 7. 1.02. Let's see if that's what the answer key was, and I miscalculated it before. This is for 25. Yeah, no, I got something different. So this was for standard deviation. So I'm sticking to my answer, unless I'm reading this distribution wrong. It says find the variance, right, and the standard deviation. Well, the standard deviation, sorry, I did my square root. Oh, wait, no, this would be the variance. I didn't take the square root yet, sorry. So let's leave this here. The variance, I'll write this below, would just be n times p times q, which in my case, right, no square root. I got 1.02. And now if I take the square root, so second square root, I would get 1.01. So I have a different solution than the answer key here. I'm sticking to my answer. I don't see what, it's a fairly straightforward equation unless I'm doing something wrong. And I think that is it, right? So that is up to 25. I'm so confident about all of them except 25. He has a different answer than I do. So if you have time right before class, ask him if there was a possible mistake or if I made a mistake. Either way. All right, good luck on the exam.